So, welcome. We are live. So, let's see if everything is working. Just double checking. And we are really live. Very nice. So, welcome everyone who's joining the stream today. So we will have some cool stuff to do today. So if you want to join via Twitch or via YouTube, feel free to chat as well. I will sometimes react to the chat. Depends always a little bit on when I find the time to look into that, but I'll try to. I don't put my chat not here on the screen actually, so you will not see it on the stream, but I'll react to it from time to time. So welcome everyone. Let's go on. Today is Gleam Day. So what is Gleam about? Before we start, actually, I would like to do a little bit of a whiteboard session, actually, to visualize a little bit where we're coming from and where we are going with Gleam and why, actually, especially the why is important here. So let me do that first. So basically what we want to do is actually we want to build this nice little local first application, and we want to use Tauri. And we did this already last stream. We started actually to use Tauri and building an application, and we used it together with Phoenix Live View, which was an interesting experiment. And it took us in the end 3 hours to get this whole thing working, but we got it working, which was pretty nice. The problem with it, and that's what I would like to explain here a little bit, is that this is not an ideal setup. And let's first start actually with what a Tauri application actually looks like. So if you look actually at Tauri, what you get is basically you have your web view. The web view is actually the trick that Tauri does. Instead of Electron, it doesn't bundle the whole provided by your operating system. So this is the WebKit view that Safari uses on the Mac, and this is Edge, basically Chromium on Windows, and it's something called GTK WebKit on Linux. And on Linux, you have the additional wonderful problem that every distribution might have a different version of this. Sometimes in the case of Ubuntu, that's also a quite old version. But yeah, at least the operating system provides this. And the second thing you have actually is you have this little application here, which is basically the Tauri app. So basically what happens is you have this application, you start this application, and well, this is written in Rust. It compiles to a native binary. You start this native binary, it will actually initialize this web view. And within this web view, it will launch your wonderful application. And this one gets solid borders. And so this is actually your app. Or better, in my case, it is of course my app. And that's basically how it works. So there's a web view provided by the operating system, and there's my application being launched within the web view. So this is the way how Tauri is actually designed. And of course, there's somehow the management that Tauri does. So Tauri creates this web view, and it also manages it. And yeah, that's basically the setup of a normal Tauri application. You get the whole thing bundled as a desktop application. It runs on Linux, on Mac OS. And you can even, with Tauri V2, you can even bring this to iOS and Android, which is actually a pretty nice thing. When I started this project, actually, I didn't even consider to go on native or on mobile platforms. But after I started playing with Tauri, I realized, well, maybe mobile is not such a bad idea, at least as a perspective feature in the future. We will not start with that, but maybe later. And to run actually your application in the web view, it needs to compile to JavaScript or to WebAssembly, and then you can run it. What we did last week, or no, on Sunday actually, in last stream, is we wanted to try something different. So what we did basically is we created this, we also have our Tauri web view, but this web view actually doesn't contain this big application here. Instead, we put a very tiny application in it, which was just listening on local host 4000. And this tiny little web application is actually just, well, in this case, it was really just a browser. We used the web view just as a browser because this localhost 4000 actually, we also of course had this Tauri app over here that manages the web view, and the Tauri app also managed another app which was our Elixir application. So we had this nice Phoenix live view application that was running somewhere in the background, and both of them have been managed by Tauri. So we did this using the Tauri sidecar functionality, and then localhost actually of course pointed here to our Phoenix application, and we were able to run this. So the good thing is actually after 3 hours we got this whole thing working, but there's few problems with that, and that's actually where Gleam comes then in, because Gleam follows more the traditional way of or Gleam can be used in the typical way how you would use Tauri, and then you don't have the problem. That's actually the reason. But the point is actually, if you build an application, if you build this like this, actually, we managed this all. We bundled actually our Phoenix application as a single executable binary that was started by Tauri using the Burrito tool and all the stuff. And we ended up with a couple of manual tasks to do to actually build this and bundle this and run this. And it would probably take some time to automate this. It doesn't work out of the box. Another thing is here this localhost 4000. So this is a tool that is targeting software developers. And now let's say a software developer is running this application and at the same time opening a terminal and running a Phoenix application for development on localhost 4000. So this will not going to work. So using localhost 4000 is not really working, so we would probably have to use a random port that is a much higher number, or even better, a Unix socket, which would probably also work. The way this had to work is then going through Tauri. So basically you can register in Tauri a custom scheme, and then this custom, and we would replace the localhost 4000 here with our custom scheme. It would call the Tauri application in the background, and then Tauri can forward the request to the random port or the Unix socket here. At least on Unix-like operating systems, this would work, not on Windows. There we had to use then the random port, but still. Another problem I mentioned already is Tauri supports mobile devices as well, and I read on the internet that it's possible to run an Erlang application on a mobile device like an iPhone, but the tutorial wasn't really a tutorial. It was just mentioning that it's possible. So at some point, it might be an interesting exercise to figure out how this works, but actually I want to build an application that delivers some value and not play around the next half year with how I make Erlang run on my iPhone or on someone else's iPhone. So I'm not sure if this approach here with the Phoenix application is actually really something that is feasible for iOS and launching the app actually on the App Store. I'm not sure about that. So probably this is a safer bet here with the traditional Tauri approach. And since there have been several problems, so we made it working, but there's still a lot of work to do to get this actually working in a really stable and releasable way. Going this direction is much more productive. That's the simple thing. Choose actually what's easy. And by the way, hi Box Trooper, welcome to the session. So yeah, that's actually the thing. We want to choose actually the simple thing. We want to build, we want to get things done and not invent a new framework or something like that. So I looked around, what are the options? And well, what I would like to do is this application needs to synchronize somehow. So in the future, there will be at some place, probably somewhere in the cloud, be something like a sync server. And the reason is, well, this is a local first application, and one of the principles of the local first idea is actually that at least different devices running the same application can synchronize. So doing this means that this application here needs to somehow synchronize with the server. And of course, doing this in both directions. So the sync protocol, well, I'm currently looking for, or I'm looking forward to use auto merge for that. Maybe we will evaluate YJS as well. That's something to be defined, but at least we want to use here some CRDT-based protocol to do the synchronization across multiple devices. There's a plan to do also real-time collaboration and stuff like that. So all the cool stuff. And yeah, that's something we have to build as well. And I would like to have the same language for both. And for such a sync server, actually Erlang is a very, very, very good platform because of its actor model, and you can much better handle actually the different devices being connected continuously and syncing them. And because of that, I would like to use the Erlang platform. And that was actually also the reason why I wanted to go with Phoenix here and Elixir to do that. But there is, of course, also other options on the Beam available. So one of them is, of course, Gleam. So if you haven't seen Gleam, or maybe some people have seen Gleam already. So actually Gleam is this nice programming language with the fancy star here, or cozy star. I don't know how to, it's a nice one, let's be honest. So Gleam is actually a very nice language. It's statically typed, it's functional programming, which I like a lot. It has a very nice syntax. To me, it looks something like similar to Rust, which makes it more nice, to be honest. Yeah, if you haven't tried Gleam, go to the web page, just click the Try Gleam button and try it out. So why does Gleam fit very well here? Because with Gleam, Gleam compiles to the Erlang runtime, so I can basically write my sync server with it, and it compiles to JavaScript as well as a first-class target or compiler target, which is nice. So I can also write here a single-page application that I can ship within my web view, and so it fits very well, much better than the Phoenix approach here with the live view, which requires me to run this as a separate process, while here I could just fit, it just fits into the architecture of the Tauri framework here. And that's why I decided to switch over. I also did a little exercise on that and looked for a short moment on alternatives, because I thought, well, maybe Gleam is not the only language that compiles to JavaScript and the Erlang platform. And I really found an alternative, and that's PureScript, which also compiles to JavaScript and to the Erlang platform. But the problem with PureScript is, as much as I find Haskell very interesting, a language that comes with a Haskell syntax and a Haskell type system is probably not the best thing to choose for this open source project, where I also would like to have contributions later. It's probably something to choose if you really don't expect someone to contribute, to be honest. I think Haskell is a really nice language, PureScript probably as well, but it is definitely more difficult to learn than Gleam. Gleam shares actually with Golang the idea of not having too much features and not having a too complicated type system, so that it's easy to learn and easy to adopt. So this makes Gleam just a much better fit in this case. Hi Haley, welcome to the stream. You can always add live view features back to your Lustre app in the future. Yeah, that's true. I saw also in the guide here for Lustre, there is something about server components, and there was also an example on doing this with WebSockets and having a more live view style approach. So I know about that. That's a cool thing, and I really appreciate that the framework is not just limited to one approach, but it opens up actually everything. You can do this you can do this with HTMX if you want. You can build a single page app. You can go the Phoenix live view style, and that's actually pretty cool on this. So as already mentioned, there's this framework Lustre, and this is a Gleam web framework, and that's a pretty cool one because, well, it supports right now the most important feature. We can actually build a single page app. So with Gleam and Lustre, we can actually build something that fits into this web view exactly in the way we want it. And yeah, that's actually why I decided I will not continue the experiment with Elixir and Phoenix Live View, but instead give Gleam a real serious and honest try. So let's do that then today. I have to admit, I'm not a very good Gleam programmer yet. I have experimented a little bit with it, but I'm far away of knowing all the syntax parts. So this might be more a rough programming today. But first we want to get the project working anyway. So let's start with that. So actually in the Lustre documentation, let's just follow the quick start. There are actually everything that we need here. So basically we want to create a new app in Gleam, and we want to add the Lustre framework to it. So let's just do that. Wait, what happened now? No. Okay. So thanks, Haley. Yeah, I'll ping you on the Discord, definitely. I'm pretty sure I will get stuck, and I'm pretty sure I'll ping you on the Discord. But thanks for being so responsive, by the way. So this is actually one of the things I really learned about Gleam. It has a fantastic community, especially on the Discord. Everyone is very responsive, very, very well supported. I really like that. So not just a fancy star as a mascot, but also a really, really, really great community. Very lovely people. Great. So let's start now with creating our application. So we will just do that with this command. So we create a new app, and we add actually Lustre to it, which is a web framework. And as the documentation says here, we need to add in the Gleam toml, we just need to, come on. we need to add the target JavaScript. Because by default it uses Erlang as a target, that's the default one, and JavaScript needs to be added here as an alternative target. That's not the default. So that's basically it. So let's follow just the standard example here. So because we named our app actually app, there is in the source directory, there is of course an app.gleam file, and we can just override this one and well, have something that will hopefully work. So let's give this a try. What does the documentation say? We can add the dev tools here. Yeah, that's something I had already some fun with. Let's do that. And then we can just run the dev tools. So up to now, until now, we just did basically copy and paste from the quick start guide. But I hope we see already something working here. At least that's what should happen. Some compile warnings. And on the wonderful port 1234, we should now see an application running. So let's open this one, not 4000, 1234, and hello world. Yeah, great. So the application is working. That's exactly what we wanted. And let's see what's in the application actually. So we have the priv static here with the app MJS. So what's this? We can quickly look into that. Priv static app MJS. So, well, this is basically the JavaScript that has been compiled from our Gleam application. There's a little bit more JavaScript in than in our Gleam application, but I think that's fine. Yeah, that's basically it. So if you have been using Elixir before, priv static should be pretty familiar to you, because that's also where Phoenix, for example, puts all the static assets. So there's actually no surprise here. We also have the index HTML. So let's have a quick look into index HTML. So this also looks just like a normal index file. Index HTML file of a single page application. So we have actually the app MJS being loaded here. So there's no surprise actually. So the next thing we will do, because in the end we don't want to run just the Lustre application in the web interface, we actually want to use Tauri again. So let's go to the Tauri quick start as well, or actually create a project. And of course we'll use the cargo version. So I've installed already all the stuff here, and I can now run the create Tauri command. We did this already last time. So what is the name of this project? This is Cozy Coda, and the package name is not this, but this, the Cozy Coda identifier. Choose the language. Let's choose JavaScript. Let's choose NPM, and let's choose, I don't know, vanilla. Vanilla JavaScript. This is just because the tool doesn't allow us to skip this part, but we will just remove that. So if we look here, it didn't actually modify our directory here. Wait, what is Cozy Coda? It did. Okay, so it created actually in the Cozy Coda directory, it created actually a JavaScript project. Ah, okay, so it put everything there, which is not correct. That's not what we want. What we actually want is we want the, actually we just want the source Tauri part here. So let's just copy over the source Tauri directory to here. And yeah, now everything should be here. Let's quickly look what the git ignore is saying. Yeah, we can ignore this one because it's just for JavaScript. So basically we can just remove the rest of the cozy coder directory because it's just the JavaScript part. So if we look into this source-Tauri application, what we will see is we have a cargo toml here that comes with all the descriptions. So we have the cozy coder application here. This is actually how a Tauri application looks like because it's written in Rust. There is a git ignore in it, a libRC file actually, which sets up our application, a main RS file that runs the application, a lot of default icons, some default capabilities that we don't have to care that much about now, and one thing is missing. Wait. Where is the Tauri.json? Ah, yeah. Why didn't I see that? Okay, and that is actually the main part here, the Tauri.conf.json file. So this is actually how we configure our application. So here's the identifier. This is the front-end dist-dir, which is not correct. As we already saw, the directory where our front-end lives is actually priv static. So why is this? So the front-end dist-dir is in Tauri is actually the place where all the application stuff, or the single page app actually lives. So all the stuff that that our Gleam compiler creates is actually in it. And I just realized that's not correct because our index.html, which is expected to be in the front-end dist-dir, lives in the root directory. So this is probably not gonna work. So the correct one is probably this one. We will probably adjust this later. Let's see how this works. So we basically have everything here except one part, and that's, let's see how you manually create this if you want to. So we have we should have run Tauri init because then it does this here. And we could have provided the correct commands here. Now we have to figure out how to do that. I think that's in the configuration. There is a build configuration and the build. Was there also no bundle? No, should be the build config then. Ah, yeah, here before build and before bundle. So the before build command is a shell command to run before Tauri build kicks in. So what this means is we can just use that one in the build config here. So we have here our build and we have our front-end dist as one property in it. And we can now enter the before build command as well. And the before build command is the Gleam run -m Lustre / dev. Wait, let's see how it was. Start. Ah, nice. Okay. Of course, I missed the comma. And the before bundle comma. Ah, no, the before def is the right one. Exactly. So there are different of these commands here. So before build is actually the one that is executed to build and compile your application. So this should be something like Lustre dev build. And then we should have the before def command, which is executed before Tauri def. And that's actually the one I was looking for. So this one now needs to be Gleam run -m Lustre dev start. And what we also need is the def URL. So what is the def URL? The URL to load in development. And we already know what the def URL is. Because that's the http://localhost 1234. So with this in place, we should be able to just run cargo Tauri, not build, but dev. So if we now run cargo Tauri dev, what will happen, of course, because this is a Rust command, it will launch a lot of, or it will compile a lot of Rust code. So this might take a while, but let's run it. So we execute the before dev command. No, we first compile. Okay. So it now compiles the Rust code, which of course takes a little bit. So we are halfway through. And it is compiling and compiling and compiling. We are almost done. Yeah, if you missed this on the last stream already, I mentioned this. So currently, until my new laptop comes, I'm running on Windows and using WSL here. And what's interesting is that WSL also supports graphical user interfaces from Linux. So what we are currently doing is we're compiling the Linux target here in an Ubuntu environment. And when the application launches in hopefully a few seconds, then this is running in this is actually a Linux desktop application and a Linux window shown by Ubuntu, although we are running on Windows, which is an interesting thing. I didn't know this before. I played around with Tauri that this is possible. And we are done with compiling. So somewhere in the background, it should have started also our Tauri application, our Gleam application. And guess what? Here it is. This is actually the Linux window, title Cozy Coder. And here we see Hello World. That's exactly the Hello World that we have seen before. And we can even see that this is having our priv static app MJS. And well, this is our Hello World that we rendered from our code. So if we look here into the Gleam app, this is actually the Hello World that has been rendered. So let's see how well this works. What happens if I just change this to hello developers? So what happens is it automatically updates. So all the hot reload functionality is also in place. So everything works as expected. So now we can just leave this window running here. We have an inspector or a web console being shown. We can print to the console. We can look actually for network interactions, although this doesn't matter that much to us. But we can use all kinds of things here, like inspecting our HTML right in the window that we created here. And whenever we change the code, this will just compile and be shown. So this is exactly the kind of thing that we wanted to have. So success. And the cool thing is this was much quicker than actually setting this up in with Elixir, because of all the burrito compilation and packaging and so on, which took way more time compared to this setup. And the reason is not because Elixir is complicated, but actually Gleam and Lustre just fit into the concept of Tauri that is easiest to use. So let's close all of this and do one last thing. So we of course don't want this app in a subdirectory. Let's move one up and let's move everything from app here. And let's do the sign like this. Okay, cannot override the Git directory. That's fair. Let's see what is in the Git directory. In the GitHub directory. So workflows, test YAML. Yeah, that makes a lot of sense. We want this as well. So yeah, let's just drop it here for the moment. Ah, come on. That's of course not what we want. Line numbers are not needed. So let's remove them. I will clean this up later. Let's first commit the rest actually. This one we will remove. This one, I don't know if I want to check this in actually. Let's not do this for the moment. So we have our app.gleam. We have the capabilities. We have a lot of default icons. Let's just keep them as they are. We have our librs and our main rs. The git ignore for the Rust codes, of course cargo log, cargo toml. Yeah, some build rs to do the Tauri stuff, the Tauri configuration itself. We have a Gleam test, which should still work. Let's give it a try. No, it doesn't. File exists. That's nice. Why does the file exist? Ah. Nice. The test runs. We'll update this later. We'll not update this one. Gleam toml is needed, the HTML is needed, and the manifest, of course, as well. So here we go. The first stuff is done. So now we have a few things to clean up. One is actually the app MJS. I'm not sure if I want to commit this. Actually, I don't know why. But let's now continue actually with doing actually something. So because before we run something, as we had before, let's start the application again. And we want to build some, let's start with some user interface stuff, because me as a backend developer, mainly a backend developer, this is probably the most struggling part. So let's give that one a try first. Yeah, but let's run the application first and then see if we can add some Tailwind here and see if we can actually do some UI things. Unknown source. Maybe because I moved all of this. Wait. And then Gleam test. Good. Gleam run dev start. What happens now? It compiles. And it compiles further. So nothing going on in the chat. So people listening and watching, what are you working on right now? So this works again. Anything you want to share? Cargo Tauri dev, and we should be running again. No, it doesn't. Erlang open port, unknown source. Why did it work before? It doesn't now. Let's compile everything once again. That's a weird error, especially since the Erlang runtime doesn't work here. So why does it work otherwise? It tries to run ES-build. Bundling with ES-build. An error outside of Gleam. Okay, it's not an Erlang error, it's an error outside of Gleam. But why? That's weird. Let's try this once again. What did I change here? That doesn't work. Because when I run Gleam Lustre dev start, it runs. This is a normal before dev command. If I run it, it will work. That's a weird error, especially since it worked before. Is there anything else in the source story? What is this gen directory? Okay, let's remove that one as well. Yeah, the interesting thing Haley, the interesting thing is it works when I run this manually, but it doesn't work when it's invoked from the Tauri framework, which is weird because the only thing that I changed is actually I moved all the code just one directory up, and that's weird. But I think there's something cached by Tauri that is not correct. So let's try to. Yeah, it's not moving them around. Maybe it's trying to execute this in the wrong directory or something. I'm trying to get rid of everything that is not under Git. Actually, that's probably the right strategy. Hopefully, the right strategy. So also, no, that's not. So let's give it another try. No, still not working. So why should Tauri do that? Let's no. Also nothing. Okay. That's interesting. But the error we get here, I even don't know what exactly the error is, to be honest. An error occurred outside of Gleam. Yeah, I think so as well. But the weird thing is that this before def command should just work. You know, that's the weird thing. Maybe we just switch into the source Tauri, which is actually not necessary, but let's give it a try. Maybe this works. And this was also quite weird because normally, so now I run this in a different directory and it just compiles everything because I removed actually the target directory for Rust, and it didn't recompile everything, which it has to because otherwise it cannot run the Rust code, obviously. And I'm a little bit confused why it didn't do that. So now it does this, that I execute this in the different directory. Yeah, maybe some issue that some caching of Tauri somewhere where we didn't expect this. So let's hope that this will now fix it. But again, this is Rust compiling. This will take some time. Waiting. Yeah, I think so as well. So it looks a lot like there's some ugly thing that Tauri does here, like caching or so, that creates actually an error that should never happen. And especially when I run the Gleam dev tool start directly without Tauri being involved, everything works. As soon as I launch this from Tauri, it doesn't. But success, actually, we are running again. So it has been resolved by just executing it from that directory. Yeah, I think the hypothesis with something is broken or something is wrongly cached on the Tauri side is probably a very good assumption here. So then let's look into this. But since you're here, Haley, short question. So actually the app MJS, is this something that should be committed to Git as well? How would you treat this? Yeah, I agree. The best way. I think the reason why it is here is probably because this is just not automatically added to the git ignore. So that might be the reason. Because usually you don't have this if you use Phoenix, for example. You don't have this because Phoenix actually generates the application and puts a git ignore file there that contains already all the Phoenix things that should not be committed. And I think that's here a little bit different because we just we just create a plain Gleam application and then add Lustre just as a library, which is a much simpler approach to do. But of course, then we have to update the git ignore ourselves. So I think that's actually a good thing to put it there. So it is priv static app.mjs. And there we go. That's an interesting thing to edit it. Yeah, I don't think that it's a good idea to edit it, to be honest. Maybe a better approach would be to just add in the quick start guide, like you do with the target on JavaScript, just add a little note there that if you don't want to add this to Git, don't forget to add this to your git ignore file so that people can just copy it or so. I think that's that's less enforcing things and then leaving the choice actually up to the user or the developer. I think that might be the more polite way to do that. So great. So now we have an application that is running that is using Gleam and Lustre. So let's open up our app.gleam. This is our application. Very well. Everything there, and it works also as expected. I think we are done with the Tauri part right now. Let's stick with the Gleam part here. And of course, we will not go here to the quick start guide. That's something everyone can do themselves. But we want to add actually a little bit more boilerplate code. And it's easy to just do that by looking here at another guide. The side effects guide, I think, was the right one. Because if you're new to Gleam, like I am, then actually these guides in the Lustre documentation are pretty good. They give a very good overview. So Gleam's or Lustre actually implements the Elm architecture, which basically means you have an init function, you have a view function, and you have an update function. And the way this works is basically when you initialize your application, you run the init function, you get a model out of that. The model will be rendered by the view. So basically you have a view function where you pass in the model, and in this case you get back a message. And then whenever something happens, like someone clicks on a button or so, the message is passed to an update function. The update function decides what to do. And so the message and the model are passed to the update function. The update function decides what to do. With the model, it will, as the name says, update the model. And once the model has been updated, it will pass it back to the view. It will be rendered again, and that's it. So, of course, like React as well, Lustre uses a virtual DOM under the hood. So you not always re-render the whole document object model. You just re-render the virtual DOM, and then it gets synced. And then you have this effect stuff here. So effects are used to I think isolate the side effects actually from this functional code that is running here. And that's pretty cool, because then you have code that is most likely pure functions, only pure functions. One of the really, really cool thing in functional programming is if you have just pure functions, then they are predictable. You exactly know what they are doing. You can exactly test them as that they behave like they should. And there is never a side effect happening. And with this effect concept, you actually get the side effects out of that, so that the majority of your code base can actually be pure functions, which is, yeah, one of the real huge advantages of functional programming, and why I'm personally a big fan of it for many years already. So let's see how this looks in practice. We don't want to go through all the details here. Let's just find some copy and paste code. At least I was hoping to find some. Right. Here it is. So the way this basically works is you have the Lustre application. This is our starting point. And if we look into our code right now, what we do is basically we have just created an element, and then we run Lustre start and pass in the element. What is the examples directory? Yeah, that's true. I looked into the examples directory as well, and some stuff there is much better to copy and paste. That's true. But I think for this, this is okay. I would like to do this a little bit more from scratch myself, because I think I would like to get to a point where I could just write this boilerplate code also myself without looking into any documentation. At least for those type of boilerplate, I prefer to being able to remember this. There are some things that should just be in the muscle memory. So we have the Lustre start here. We pass in the app. In this case, the app is just an element. But what we really want to do is not pass in an app. What we really want to do is we pass in an app. And this is this app here. So we use the Lustre application to create an application. And this application then gets these functions. So we have an init function, we have an update function, and we have a view function, and all of this is passed then into the application. And the application actually is having then the runtime that makes all of this work and coordinates the different things, like executing the effects, waiting for the response, triggering the update, and so on and so on and so on. So that's what we are looking for, to use that one. And and Lustre application. Wait. And this is in the root package. Okay. So I guess what we want to do here is we want to say app is now the Lustre application, which gets an init, update, and view function. And of course, we don't need this anymore, at least not for now. So now we have the init function. So let's look back at how the init function is defined. So we need a function that takes A and returns B and an effect of C. Great. So what we definitely need first is we need something that that these types are. So in our case, this means we need a type. Now I need to look into the state guide as well, I guess. Yeah, here it was very well described. Exactly like this. So we can just define a type. That's nice. I didn't see that before. A type called message actually, and now we can define some message that we want to pass here. Let's just start with a simple greeting message. This is just an example, nothing really working. And we see here, by the way, on the right side, our application is just running in the background. So whenever I save this here, we get the compile error shown on the left, on the right side here as well. So the hot reloading is happening. And if we look here into our window, the hot reloading is also happening. So we see actually in the window as well, the compile errors being shown. But we can just ignore them for now because we know that it doesn't compile. So we have the name, and the name should be of type string. I guess this is how you write this in Gleam. Yes, no, ha. Okay, looks like this. So now what we do basically is we look back at the function definition. So we give back an effect of C. And C in this case is the message that we just created. And if we look here in the example here, we have better names, of course. So we get some flags in, we get a model in, and then we return actually the effect message. So we can actually just copy this one. So we have some flags. Interesting. I didn't know that the docs actually erase the name of the variables or the parameters. That makes sense. Good to know, actually. I didn't realize that. I thought it's just normal Gleam syntax. Yeah, I'm just too new to the language to see the difference, which can also be difficult, of course. So let's pass in this, and we have a function that returns, well, actually that is a to-do function now. And the type effect is missing. So where do we get the type effect from? I guess that is coming from Lustre, or maybe from Lustre effect. Let's see what, oh, come on, is there no type hints? password here? Ah, the effect module, okay. So then I think it's like this. Import Lustre effects. And then I think we can just do it. No, it would have been too easy. So I think it's like no. Type. We are wrong here. Type effect. I was not expecting this. Nice that you are not expecting this. I think I have to wrap this like this. Yes. So and I think this one should also be like this, isn't it? No. Yeah, I think the declaration is not the best idea. Let's also define our type model, which has now, I don't know, let's give it, wait, let's just call this an int. And then we can return here return 0 and a greeting. No, even better, we can return effect none here, which is actually an effect that is doing nothing. What? Nice. Okay, the LSP does this, that's nice. Cool, good to know. Yeah, the LSP works quite well, I have to say, for a young language like Gleam. It's surprisingly good. I think it's not as good as the Rust analyzer language server. I think that one is still one of the better ones. Also, the Go language server is quite good. But yeah, the Gleam language server already is quite good. I like it. Very good to see that the language supports this in a good way. So we have this. Then we need a function update. And the function update, I think, gets a model and a message. And it returns a model and an effect of a message, which makes a lot of sense. So we get a model of type model and message. Well, let's call it, let's stick with the naming. Message, and it returns both a model and an effect of a message. very much like the init function. So we can once again just return 0 and effect none, which is good enough for getting started. And at last we have the view function, which should get a model as an input and returns an element of message. Okay. And how does this look like? Do we have an example here? No, we have probably here an example. Awesome. Is there one in the quick start? Yeah, okay, we just can create a div tag like we did before. It's lowercase. So what's the syntax? It gets attributes and then it gets children, I think. Yes. And the children are just an array. Okay. How do I just pass in text? Ah, element text. Nice. Yeah, element is not defined. I think that's the same here. Yes. It is the same. Good. So now we have something that is more or less working, and of course we are doing almost nothing with all the stuff. So what we can actually do is we can just return here the model. We can just say that this is not used, and we should probably also do something with it. How does it do this here? No, just concatenation, right? Type mismatch. Okay, string. String. Ah, maybe it's int. Is there a two string? 2 base 8. Nice. 2 string. That sounds good. Now what's broken here? Element So unknown module HTML. That's something we can fix. HTML. Then fun with Vim. So what if we look here? Wait. Nice, the count is 0, which is true. We didn't do anything with it. Anything else? Element comes from Lustre element module. Yeah, we figured this out. Thanks. HTML text. Yeah, thanks. And yeah, cool. Thanks, Haley, for all the support here on stream. That's really, really appreciated. And I have to admit, until now, I really enjoy it to write the Gleam code. That's a really, really nice language. So let's go on with that. So now the first thing we want to do is obviously we want to do something with our model. I know we want to do something if we get a message, then we want to do something with a message. Oh, come on. So in the case that the message is no, not this, is greet with a name, we want to actually add something to the model. So giving the model just a number is probably not such a good idea. In our case, we want to give the model a subtype, and or however this is called. So person with a name of type string. So in this case, we want to wait. So we want to return a model. In this case, we want to return a person. With that name. And an effect none. Because we're still not doing any effects here. And we have a problem here. And that problem is that we should return a person with no name. Wait. Let's once again double check the docs. Where are we? Side effects. So what do the docs say? So we have a model and an effect. I wonder where this was. Exactly, here it was. So we have, so the case with multiple models actually is quite interesting. Okay, this is how you do that. So you define actually the model, and then you have another type for the login model. But Okay, let's follow Haley's advice and let's just see if we can look into the examples and find something good here. If this is easier to copy and paste, let's do that. Let's start with the okay, here it's still the count. Maybe we get this with the HTTP requests, that we get some more advanced modeling. So here we have a model of type model, and it contains actually a quote. And then we have a type quote. Okay, this makes more sense, and now I understand also how it fits. So now if we go to the update, we can receive actually the user click refresh message, and we return just the model. In this case, just the model itself. But we could also update the model by just overriding here the quote with some quote, which makes totally sense. And it's also quite a good idea to just make this an option, because then, yeah, I like this. That's actually how we should do that. So we need another type actually of person. And the person has now a name, which is exactly what we wanted before. And now we remove that one and we define a model that has a person, and the person is an option of person. And of course, we have to import the option. Okay. Really? Okay, let's do that. Import Gleam /option. And from there, we import the option type. No, that was not what I wanted to do. Ah, damn. Hey, what's going on here? Come on, this is not what I want to do. Hello? No, that's not what I want to do. Not sure. What's going on here? What's going on with my keyboard? Ah. No, my keyboard is still the same. I'm totally confused what's going on here. No information. The keys are completely broken. Ah, no. Caps lock. Caps lock. I hate it. Beaten by the caps lock. Not a Vim moment, a caps lock moment. Damn. So, unused private constructor. Yeah, I know. I know that this isn't used. So let's fix this. So we have a model, and that one gets a none. Yeah, we can also import the num. So we now return the model here of none, of course. And now in this case, we are returning the model with a person in it. And this is now a sum person. And of course, we want to import this sum as well. I like the Lustre for the Gleam formatter actually. It's such a great thing if this just formats automatically. I really love that. Okay, so we have now created a model with a person in it. We are returning this now, and we are having this one here, which is of course I think it was let, isn't it? Name equals model person. No, that doesn't work. That's true. Let name equal case model dot person. If person no, if some person, then we make the name the person dot name, and otherwise we return a default, which is our lovely developers. So now the whole thing makes a lot more sense. We don't need the int here anymore, and we can just make we can just add the name here, and here we go. So let's see what we get out of this. This is true. Okay, that looks good. We now have an unused one, that's fine. So we now have an application, a very, very simple application here. We have an init function that returns basically none, which is totally fine. The update doesn't happen right now, but it could. Actually, I think this isn't required. And now we have the view with the model being rendered, and this is now it. What we do next is we need we want to create a div around that, and a div Ah, I forgot. There can be more than one div. More than one element in the div. Great that we have static typing here. So now we have the div being ready, and we want to add actually a button to it. HTML dot button. This for the moment doesn't get any attributes. We will fix this later. And we pass in the element text. Oh wait, this is probably not really what we want. Now that I think about it. Maybe we have something here that is more appropriate. No, controlled inputs. What is controlled inputs? Let's see. So we have a main with a simple one. We have the update function. Yeah, that's all clear. So we can use UI. That's even more nice. We will do that later, but we can use a button, and the button can and a text input here. Ah, nice. I wonder, Haley, don't I have to put a form around that? I always thought it is a good practice to put a form actually around your input and your buttons and so on. Isn't this necessary here? So this is the field. Ah, you don't have to put a form around these things. That's nice. That's true, we are not hitting it back. Yeah, that's true. You need the form because then you get the browser's form serialization. Okay, that's interesting. Yeah, that makes a lot of sense. But there's also a form API, isn't it? In JavaScript that you can just isn't there a function that you can use in the browser to if you listen for the submit click on the form, you can actually have a JavaScript function being executed that gets the form serialized, and you can directly interact with it. Isn't there something like that? But probably it's also just useful if you have a backend for that. I don't know. But yeah, okay, makes sense. At least we don't need it here. That's all I need to know here. The question is, what do I have to copy? I think it's this one. So the button is not what we want, but we want this here. So now I have to import also the UI. Lustre UUID. That's interesting. Is the UI a separate library? Let's have a look into the Gleam tunnel here. Yes, it is. Oh, interesting. Nice stuff. I see already that I'm not adding any Tailwind here today. Yeah, the model is single source of truth. That makes a lot of sense. Yeah, that's actually a very good thing, by the way. Yeah, then let's add Lustre UI. You would not recommend it, but then I cannot copy the code from the example, you know. Um, yeah, I just want to get this working and to get it a little bit more interactive. I had actually the plan to use some Tailwind here as well. I saw that the DevTools somehow support this. But I think, yeah, if it looks a little bit better than it is right now, I think that's already good enough for me. This will not go to production today, let's be honest. Unknown module, Lustre UI. Lustre UI, there it is. Where's your problem? That's also a good thing. Yeah, then let's just use HTML input. That makes probably things much easier than getting everything else now to work. So, unknown record field. Did you mean person? Yeah, of course I did. Very good hint. No, I did not mean person. I meant the name. And where's attribute coming from? You uncomment out the line in the index HTML that it told you to do, and you're good to go. Okay, so it's not very useful in practice. Okay, that's a statement. Oh, it's becoming very nice. That's great to hear. I'm looking forward to use it when it's looking very nice. Thank you for that. Great. So Lustre attribute. I think the UI stuff is not needed, but the attribute stuff. So let's do it like that. And we need the Lustre event, I guess. Import Lustre event. Anything else left? Yeah, of course, we copied now all the fancy types here, which doesn't make any sense. So, we have also UI field here. What is UI field? There's no HTML field. Field set. What is actually the field here? I just copied it over here from the example as well. So here in the example, we had this, no, in the other example. In the other example, we had this UI field, and then we had the input and the button. Maybe I should just remove that one. Styled wrapper. Yeah, just remove it. Great. So what else do we have? I think that one can also go. So we have a paragraph that says hello, and then we have the input. That should actually send that should actually send a greet to, I don't know, let's figure this out soon. On input, well, let's have a look again. So we have the model value, that's true, and then the user updated message. how does this actually work here with the input? So on input, I send a user updated message, and then the user updated message actually gets a value in it. So how is the value bound? Is this automatically happening because of the attribute value? Or how does this, because in the end what we get is actually a user updated message with a value, and the value is probably the value coming from here. Ah, yeah, of course. Yeah, now, makes a lot of sense. Thanks for pointing this out, actually. Yeah, makes a lot of sense. Thanks. That's actually very, very cool. Awesome. Okay, for everyone who didn't understand this, actually, this here is just creating a function that takes one argument and passes this argument to the value in the constructor. That's great. That's actually a very fantastic feature in Gleam. I didn't remember this in this moment, but awesome. Wow, that's crazy cool. Then I don't need this actually. Wow. This makes a lot of sense. So I think this can also go. And this is then the greet button. And when the user clicks on it, we get a user clicked greet, and we need a message for that. Of course, this doesn't work anymore because the user click greet isn't handled. So in this case, what do we want to give back? We want to give back just the model, which we have to adjust. We want to give back the model and still an effect none. And I think the user entered name is probably the better name for that. So, of course, we have to adjust it here as well. Let's see what our UI is giving us. So now it's developers, and if I enter here, oh, come on. That doesn't work out of the box. Hey, hello Haley. Great, it works. At least we have now some interactivity. And yeah, you're right. If I wanted to make this more advanced, then I would probably model it like that. But right now it is just about getting some Gleam stuff working. So, well, this application should become a chat application. So I'm pretty sure greeting is not a feature that is really the stuff that we will put here. Right now it's more about getting into the Gleam and Lustre flow and getting some code out that works. And then we will actually do a real modeling later. And we have to do a lot of the cool things then, like doing synchronization and other stuff, but we need to get a little bit working first. So so this is more the Hello World day. The real stuff will come then the next time. But yeah, I think from the functionality perspective, this is already good enough. I don't want to do anything else here right now. I think we also just said that we don't need that. So let's commit this. And the last thing I want to do for today, so this will not be the longest stream today. The last thing I want to do here, how long are we streaming already? 2 hours. Well, that's okay. But the last thing that will go on actually for today is adding, of course, Tailwind. So now that we are not using the Lustre UI, we will actually try to add Tailwind. Mainly because it's the only CSS framework that I nowadays know about. I roughly know how it works, although I have no clue. And I also have a pro license for some of the Tailwind stuff. I bought this several years ago, so maybe it's still useful today. Because in the end I want something that looks okayish, but let's see. So the docs. Tailwind CLI. So basically what we need is this Tailwind config, isn't it? And well, Tailwind config JS. That's even easier. Thanks for mentioning this. Gleam run -m Lustre dev at Tailwind. Wow, that's nice. And it downloads Tailwind for Linux. Great. That's exactly. Woo, cool. That's nice. Oh, then the Tailwind integration is even much cooler than I expected. That's cool. Really great. So all I have to do is just make sure that this here is in my index. HTML. Cool. I'm in the wrong one. Index HTML. I guess this is basically uncommenting it, but more or less. Your app CSS. Ha. That's funny. How does my CSS look like then? I guess it is just this one here. It's even here. Uncomment this for adding Tailwind. Cool. That's something good. I think the just as a question, so it's not always app MJS and app CSS. It depends on the name of your application, isn't it? Or on your Gleam module, actually. So Yeah, I expected this. Great. Thanks for confirming this. Actually, yeah, makes a lot of sense to name the JS and the JavaScript and the CSS files of the Gleam module, especially since you could also have multiple applications. They could have different names, and then you could have them all in the same directory if you wanted. Although this might be an edge case. So let's also look into the priv static now. We still have the app.mjs in it. And I guess that's because we probably have to restart it. Really great. So far the experience is way smoother than I expected, to be honest. So that's actually a good sign. Yeah, let's run the dev server once again. Nice. Yeah, I think that's a very good goal. So goal for Lustre DevTools is fairly opinionated on Rails thing, where if you don't care about front-end dev stuff, we just handle everything for you. That's exactly the type of things that I was looking for. Because especially when you're coming from the back end and are not that deep into front-end development, it's even much nicer if everything just works. So now we also want to get some Tailwind stuff working. So let's see. Tailwind UI. And sign in. Let's see. No. Seriously? Oh, there is. Just not. Okay. No. Not too much convenience. And you will get back Lustre code you can copy. That's great. I like it. So let's have a quick look into the components here, and let's maybe, I don't want to do too much stuff. I just want to grab some input. How do they style actually input? Class block, blah, 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 blah. That looks nice. Let's see where we are. And we have the input, the value, the user input, and now we need I think it's attribute dot class of, what does it accept? A string. Okay. Let's see what this changed. Yeah, well, doesn't look really pretty, but at least we have something. So we also have the greet button. Let's make the greet button also greet somehow. Then we have something else that I want to copy here. Is this just input fields? Select menus, combo boxes. Where are the buttons? Data display. Let's take such an action thing here. So we have a button here. We don't really want it to make, we don't really want it to be too pretty. Attribute class. Oh, come on. That's not correct. So now we have a blue button as well. That's cool. It's interesting because I just realized this because I implemented it in the most laziest way. I get this field here updated automatically because I bind automatic. So whenever I input something, so every character I enter here is automatically stored in the person name and will automatically be rendered then here. So that's the optimization that Haley mentioned in the chat earlier, that if I would put the value from the field here in a separate field within the model, then I could actually ensure that the model, that the field value is just stored, and only if I click on the greet button, I could actually set the person's name to the value from the field. Yeah, that makes totally sense, but yeah, let's do that. Let's do that as a final change here on the code. Let's follow the suggestions here. So we can add the value as a string. So we do this in the most simplest way. And we can even make this one optional. Optional string, and we can initialize this with none. Then we can say we have some person, and so when the user entered the name, we don't want to set the person. We actually just want to set the person to model.person because we don't want to change it, and we want to set the value to name. No, we don't want to set it to name, we want to set it to some name. And now we want to change this here as well, because if the user clicks greet, then we want to return a model with some person and model value as a name, and I think that one. So, and we reset actually the name, the value. So model value. Ah, that's true. String can also be empty. Makes it much easier. You're right. Then we don't need this here. Just need name. And we can just reset it like this. And now it works. Where's an empty person name? Yeah, that's true. An empty person name doesn't make sense, but the value makes sense. It's totally fine. So now we need to render this as well. So the attribute value is the value of the model. And that should be it. So now it's empty. So if I now enter, and it renders developers by default, which is also fine. So now, where's the set? Here in the view, okay. So now we can enter some name, array1. It doesn't change, but if we click read, great, thanks. Yeah, that's the much better better way to do that. So now it works. We have a little bit of styling, not pretty, but it works. And we can just add this code here to Git as well, but there's one thing that we should do as well. And that's, what was this? We want to do the git ignore, and I want also to add pref static apps CSS here. So let's add this as well. Nice. And let's push it to the remote. Awesome. Yeah, so thanks Haley for all the great support here. And yeah, thanks everyone else being on the chat. So now we have at least a Gleam application. I'll probably tomorrow or so clean this code a little bit up and add probably something like a CI build. But yeah, then we will have the next streaming session and actually start working on our chat UI, which is what we really want to do. So until then, I hope I see you all again in the next session in a couple of days, working on some chat tooling. And yeah, well, thanks for being here, and build something cozy until then.